Hello everyone, welcome back to Physics online classes for class 12 students. Let us continue chapter 3 current electricity. We have completed theory part regarding current electricity and today I am going to solve NCERT numerical problems based on the chapter current electricity. The first problem is the storage of battery of a car has an EMF of 12 volt if the internal resistance of a battery is 0.4 ohm. What is the maximum current that can be drawn from the battery? So we have to find maximum current. First you can note down the givens. Here EMF of the battery is given. Let us take it as E equal to 12 volt. The internal resistance of the battery, internal resistance is denoted by small r is equal to 0.4 ohm. Now we have to calculate maximum current. Current is denoted by the symbol I. Yes, we have the equation, direct equation you can remember here I equal to E divided by R plus R. So this equation we can use to find maximum current. But here external resistor R value, it is not given here. You can observe the problem. R value is not given, so leave it. So the equation can be written as I equal to E divided by R. Substitute the value. I equal to E value is given 12 volt divided by internal resistance is 0.4 ohm. 12 divided by 0.4 ohm is how much? We will get 30 ampere. So maximum current that can be drawn from the battery is how much? 30 ampere. Second problem. A battery of EMF 10 volt and internal resistance 3 ohm is connected to the resistor. If current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when the circuit is closed? Yes, here we have to find terminal voltage of the battery. Yes, what do you mean by terminal potential difference or terminal voltage? It is potential difference across the ends of the cell when the circuit is closed or when the current is passing through it. So we can call it as a terminal voltage. See here, first we can write the givens. A battery of EMF E equal to 10 volt and internal resistance is 3 ohm. If the current in the circuit I equal to 0.5 ampere, then what is the resistance of the resistor? That means we have to calculate capital R as well as terminal voltage which is denoted by the symbol V. Yes, see here a cell, this is a cell or a battery. This battery is having certain internal resistance and the terminals A and B. This is connected to external resistor capital R. Right? Yes. So we have the equation I equal to E divided by R plus R. Substitute the value, we will get capital R. Capital R indicates resistance of the resistor. Easily we can find R using this equation. Yes, now substitute the values. I is given how much? 0.5 ampere is equal to EMF of the battery is 10 volt divided by capital R, keep as it is, small r internal resistance is given 3 ohm. Or we can write R plus 3 is equal to 10 divided by 0.5. So the calculation will be very easy. R plus 3 equal to 10 by 0.5 is how much? 20. So R equal to 20 minus 3. So we will get resistance of a resistor is 17 ohm. Similarly, we have to calculate a terminal voltage. Yes, terminal voltage is given by the equation. Yes, what is the equation? We know that V equal to E minus IR. We have to use this equation to find terminal voltage. Now substitute the values. V equal to E value is 10 minus I value is 0.5 into internal resistor is 3. So V equal to we will get 10 minus 0.5 into 3 will be how much? 1.5. So 10 minus 1.5, that gives 8.5. V equal to 8.5. What is the unit? Volt. So this is terminal voltage value. So resistance of a resistor we got 17 ohm and terminal voltage is how much? 8.5 volt. Third problem, three resistors 1 ohm, 2 ohm and 3 ohm are combined in series. This is the series combination of the resistors. What is the total resistance of the combination? First question. Second one, if the combination is connected to a battery of EMF 12 volt and negligible internal resistance, obtain potential drop across each resistor. See here, there are three resistors. You can observe the first question A. We can consider three resistors. These three resistors are connected in series. 1 ohm, 2 ohm and 3 ohm. They are connected in a series. This is a series combination. What is the total resistance of the combination? We have to calculate. Yes, we know that resistances are connected in series. So we have the equation Rs is equal to R1 plus R2 plus R3. Now substitute the values 1 plus 2 plus 3. We will get 1 plus 2 is 3, 3 plus 3 will be 6 ohm. So this is R equivalent. Right, then B question. If the combination is connected to a battery, let us consider this combination is connected to a battery and it is having EMF how much? 12 volt, E equal to 12 volt. These resistors are 1 ohm, 2 ohm and 3 ohm where internal resistance is negligible, so leave it. So when it is connected to a battery, we have to obtain potential drop across each resistor. See here, current is flowing from positive terminal of the battery to negative terminal of the battery. So we have the equation using Ohm's law, V equal to IR, or we can use I equal to V divided by R. But here I can consider V divided by this is RS or R equivalent, because we want the total current which is flowing through the circuit. So we can substitute the value. EMF of the battery is 12 volt divided by resistors connected in series, we got 6 ohm. So 12 divided by 6 means we will get 2 ampere. I equal to 2 ampere. This is the total amount of current flowing through the circuit. But we want a potential drop across each resistor. Now let us consider V1 is a potential drop across the first resistor, V2 is a potential drop across the second resistor, V3 is a potential drop across each resistor. So now we can write the equation V equal to or V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So these equation we can use to find potential drop across each resistor. Now easily you can substitute the value. What is the value of I? We got 2 ampere. R1 is 1 ohm. Similarly, V2 equal to IR2. 2 into R2 value is 2 ohm. V3 equal to IR3. I value is 2. 2 into R3 is 3 ohm. Now we can easily got the answer. 2 into 1 will be 2. 2 into 2 will be 4. 2 into 3 will be 6. What is the SI unit? Volt. So we can write 2 volt, 4 volt and 6 volt. So these are the potential difference across each resistor. Fourth question. Question A. 3 resistors 2 ohm, 4 ohm and 5 ohm. They are combined in a parallel. This is parallel combination. What is the total resistance of the combination? First question. Then second question, if the combination is connected to a battery of EMF 20 volt and negligible internal resistance, then determine current through each resistor and total current drawn from the battery. Now we can solve the first question. Three resistors, 2 ohm, 4 ohm and 5 ohm, they are connected in parallel. Let us consider the first resistor is 2 ohm, second resistor is 4 ohm and the third resistor is what? 5 ohm. How they are connected? They are connected in parallel. Right? Then we have to find the total resistance of the combination. Yes, what is the formula? We know that when the resistors are connected in parallel, resistors are connected in parallel, we have the equation 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Easily you can calculate the values. 1 by Rp equal to 1 divided by 2 plus 1 by 4 plus 1 divided by 5. So we will get the answer 19 divided by 20. Right? You can take the LCM, you will get 19 by 20. So Rp equal to how much? 20 divided by 19 ohm. This is for parallel combination of three resistors. Then second question. If the combination is connected to a battery, suppose if this combination is connected to a battery of EMF E equal to how much? 20 volt, then we have to calculate current through each resistor. Yes, suppose if the I current is flowing through the circuit, here at this point, this current will be divided. How it is divided? Suppose I1 amount of current is flowing through resistor R1, I2 amount of current is flowing through the resistor R2, I3 amount of current is flowing through the resistor R3. So this total amount of current I is divided as I1, I2, I3. The sum of all these current, that gives total current I. Right? Now we have to calculate current through each resistor. So we have the equation I1 equal to V divided by R1. We have this equation V equal to IR. I equal to V divided by R. So this Ohm's law we can utilize here. Similarly, I2 equal to V divided by R2. I3 equal to V divided by R3. Now substitute the values. Yes, V value is given how much? 20 volt divided by R1 is 2. V by R2, 20 divided by 4. V divided by R3, that is 20 divided by 5. Yes, we will get 20 by 2 will be 10 ampere. 20 by 4 will be 5 ampere. 20 divided by 5 will be 4 ampere. So these are the current through each resistor. And the total current drawn from the battery is how much? Total current we can calculate. Total current I is equal to I1 plus I2 plus I3. Substitute the value 10 plus 5 plus 4, that gives 19 ampere. This is the total current drawn from the battery. Right? Then fifth problem, at room temperature 27.0 degrees Celsius, the resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm? Given that the temperature coefficient of material of the resistor is 1.70 into 10 raised to minus 4 per degree Celsius. Right? Yes. You already studied in PUC first year the chapter Thermal Properties of Matter. There we have studied about conduction, convection and radiation. And also we studied linear expansion, superficial expansion and cubical expansion. When the temperature increases, a linear expansion takes place if you are going to consider a rod. You can remember this equation, L equal to L naught 1 plus alpha delta T. This is what? Linear expansion, right? But here resistance of the heating element we have to consider. Instead of L equal to L naught, we can take R equal to R naught 1 plus alpha delta T. This equation I am going to use here to find temperature of the element if the resistance is 117 ohm. Yes, first we can write down the givens. T naught is initial temperature 27 degrees Celsius. Right? Then we don't know final temperature, that is question mark. Then what else given? Resistance. Initially resistance is 100 ohm. When temperature changes, so that resistance value increases from R0 to R1, R1 equal to 117 ohm. Then alpha value is already given, that is temperature coefficient 1.7 into 10 raised to minus 4 per degree Celsius. Now substitute the values. R equal to R0, 1 plus alpha delta T. R value is how much, or you can take here R equal to, we can write here R naught plus R naught alpha delta T. Just we multiplied R naught here. R minus R naught equal to R naught alpha delta T. We want delta T here. So delta T is equal to R minus R naught divided by R naught alpha. Delta T is a change in temperature, so we can write T minus T naught is equal to R minus R naught divided by R naught alpha. So T minus T naught keep as it is, which is equal to, substitute the values. R value is 117 ohm minus R naught is 100 ohm divided by R naught is 100 into alpha value is 1.7 into 10 raised to minus 4. So calculate this value, we will get T minus T naught is equal to 1000. You can calculate these value, you will get how much? 1000. So therefore T is equal to 1000 plus T naught. T naught we can take to RHS side, it will become plus T naught. So T equal to 1000 plus T naught value is 27 degrees Celsius. So we will get the final answer 1027 degree Celsius. So this is the temperature of the element if the resistance increases. Right? What is the final answer? 1027 degree Celsius. Then sixth question. A negligibly small current is passed through a wire of length 15 meter and uniform cross-sectional area 6.0 into 10 raised to minus 7 meter square, and its resistance is measured to be 5 ohm. What is the resistivity of material at the temperature of the experiment? So first we can write down the givens here. Length is given 15 meter. Area is given 6 into 10 raised to minus 7 meter square. Resistance value is given 5 ohm. The question is, what is resistivity of material? Resistivity is denoted by the symbol rho. Yes, we know that R equal to rho into L divided by A. We want rho value, that is resistivity, rho equal to R A divided by L. Everything is given, substitute the value, you will get resistivity of material of the wire. R value is 5 ohm into area is 6 into 10 raised to minus 7 divided by length is 15. So rho equal to 5 into 6 will be 30. 30 into 10 raised to minus 7 divided by 15. 15 ones are 15 twos are 30. So rho equal to 2 into 10 raised to minus 7 ohm meter. Ohm meter is the SI unit of resistivity. Yes, rho equal to 2 into 10 raised to minus 7 ohm per meter. Yes, again we can continue in the next class.